Good morning. This is my second lecture of straight line. As far as what I can recall, that in the previous lecture I have completed up to the area where the coordinates are given, and we are finding the area of polygon or triangle in a specific method I have told. Right. So today we are going to find the area of a parallelogram where equations are given. Parallelogram equations are given, and we are going to find that, right? So just I am drawing a parallelogram. Suppose this is a parallelogram. I am writing the equations. Okay, suppose the equations of lines of the parallelogram is like this. Let us say ax plus by plus c1 equals to 0 and ax plus by plus c2 equals to 0. These two parallel lines, and the opposite other two is cx plus dy plus d2 equals to 0 and cx plus dy plus d1 equals to 0. So whenever we are calculating the area, what we know that area of a parallelogram is base into altitude, that is area is base into altitude. Suppose taking this as a base, then altitude will be this one. If I take base lies on the line ax plus by plus c2 equals to 0, then perpendicular is the altitude that is passing from one of the vertex of the line ax plus by plus c1 equals to 0. So we can write, suppose the parallelogram is ABCD, then I will write AB into P1. What is AB? Suppose the angle of AD and AB is theta, let. So suppose this is the perpendicular. Okay, if this is the perpendicular, suppose this is the perpendicular, so this distance is P2. The perpendicular distance taking CB, extended CB as a base, if the point passes from A to the line that is externally extrapolated, right? This is the another perpendicular distance. It can be we can also write, suppose this point is M, external point, we can also write P2 into CM. Both are correct. Taking AB, first one taking AB as a base, second one taking CM as a base. Right now let us consider the single one, and we will go through the single one, and we will come across how to change the AB part in terms of P2, right? As this is theta, then this angle is also theta, interior opposite angle. Then AB can be written as, this one is P2, then P2 over sine theta cross P1, that is area is P1 P2 over sine theta. Now I need to get the value of P2, P1 and sine theta. So P1 is the perpendicular distance between ax plus by plus c1 equals to 0 and ax plus by plus c2 equals to 0. Then we can write c1 minus c2 over root over of a square plus b square mod of this. We know that distance between two parallel lines, and in case of parallelogram, the distance between two parallel lines is also the perpendicular distance, we know. and P2 will be d1 minus d2 over root over of c square plus d square. Clear? What will be tan theta? Tan theta is the slope of the line cx plus dy plus d2 and ax plus by plus c2. This is theta. If tan theta is the slope of the line containing both cx plus dy plus d2 and ax plus by plus c2, right? So tan theta will be from this equation, that is for two lines it will be m1 minus m1 m2 over 1 plus m1 m2. This is the formula. So we write minus c over d plus a over b 1 plus c over d plus a over b. This is the equation. So from here we get AD minus BC over BD plus AC. From here if we get tan theta, then by conversion we get sin theta is AD over BC. You can calculate. If tan theta is this, then sin theta you can easily calculate. It will be suppose like this: a square plus b square into c square plus d square under whole root. This is the sin theta. Then if I change this p1 p2 and sin theta by its equivalent c1 c2 a small b, then what you will get? Area equals to p1 means this c1 minus c2 dot root a square plus b square into d1 minus d2 dot root c square plus d square into ad minus bc by root over of a square plus b square dot bracket c square plus d square. That means these roots are going to cancel, and what you will get? Just you will get c1 minus c2 d1 minus d2 in over a d minus bc. This ad minus bc is also written in determinant form in sometimes like this: ad and bc, also written in determinant form you can write. So the area is you need to, if you can memorize it's okay. Then if you understand the way I have done the derivation, then it would be more easier, because you will get through many formulas in circles and in parabola, hyperbola, ellipse. So it's definitely tough to memorize all the formulas and ultimately vomit in the exam, right? So if you can understand the way I derived, then it will be very much easier to solve any other problems also related to this, right? This is the area, right? Now let's go to another note for the new concept, that is in our book you will see that all the straight line general equations are represented in the form of ax plus by plus c equals to 0. That is general equation represented by ax plus by plus c equals to 0. So from here, if I want to get the value of x intercept and y intercept, then how can you get this? So to get we know that intercept form is like this, right? So I need to convert this equation in the form of this. So to convert this, you write in this manner, and x over minus c plus by over minus c equals to 1. That is x over minus c over a plus y over minus c over b equals to 1. This is the intercept form. So from the general equation, we can say that this is the x-intercept, and this is the y-intercept. If you want to represent it on a graph, then it will be much easier. That is, x-intercept means this will be minus c over a 0, and this will be 0 minus c over b, right? This is the way we represent. If you want to represent in slope intercept, that is y equal to mx plus c, then that is y equals to mx plus c. Then I need to take x and c, say capital C, like that, x and c in right hand side. So by equal to minus c minus ax, or y is minus c over b minus a over b in x. If we compare with y equals to mx plus c, we will get this is m minus a over b. This is the slope, and the constant is minus c over b. So if we want to show, then if suppose minus a over b is acute, taking is suppose acute, right? Tan theta is acute. So like this, suppose not acute, like this is minus c over b. Suppose this theta equal to acute, suppose I am taking, then it will look like this. This c is minus c over, this constant value is minus c over b, and slope is minus a over b, right? So in another way, we can also perform for normal form also. That is, I have shown you the normal form is x cos alpha plus y sin alpha equals to p. So let's go in another note, is x normal form x cos alpha plus y sin alpha equals to p. I have done normal form. So when we are doing normal form, we show like this. This is p, right? And this angle is alpha. So when you are converting this general equation into normal form, what we generally do, we perform like this. This is positive, so I am taking this is also positive, right? So if you take in this manner the equation, that is dividing by root a square plus b square, that is the coefficient of x and y we are dividing. So if we compare this, suppose we are comparing this and this, comparing the 1 and 2, then what we can say, cos alpha is minus a over root a square plus b square, and sin alpha is minus b over root of a square plus b square, and p is c over root a square plus b square. This is very easy, right? Nothing to go inside about this. So the next concept is concurrent lines. I hope it is known to you, but still some more insight I can give about the use of m1 m2, that is perpendicular lines condition, that is m1 m2 equals to -1. So let's do it in another slide. What you know about the concurrent lines? Suppose you know from the very beginning, you have heard the name incenter, orthocenter, circumcenter, centroid. So again I am recapitulating the definitions of that. Centroid means the point of concurrence of three medians. That is, median means a line that divides two halves. The length gets divided by two halves. That is, suppose this is a triangle, a line that divides this baseline by two halves. This point of concurrence, this point of concurrence is known as, I have told, centroid. These are the medians, this. What is the incenter? Point of concurrence made by the angle bisectors of a triangle. That is, suppose I am showing, suppose this angle bisector, that is this angle, this angle, this angle, this angle, this angle, this angle. Suppose these are the angle bisectors. The point of concurrence of the three angle bisectors is known as incenter. What is orthocenter? The point of concurrence of three perpendicular. That is, suppose this, and this. This point is orthocenter. And what is circumcenter? The point of concurrence of the three perpendicular bisector, perpendicular as well as the bisector. That is, this is the perpendicular as well as the bisector. So suppose perpendicular as well as the bisector, and this point of concurrence is known as circumcenter. And the circle that remains inside the triangle is also known as circumcircle, and the radius of that circle is known as circumradius. Right? This is the basic insight. You know that if in a triangle the coordinates are given x1, y1, x2, y2, x3, y3, then centroid is x1, x2 plus x3 over 3, y1 plus y2 over y3 over 3. For orthocenter and circumcenter, what we use the concept of parallel lines, right? So suppose for orthocenter, this, suppose this is ABC triangle, and this is, suppose, orthocenter O. This is M, N, P, suppose these lines. What we oftenly do, slope of AB dot slope of OM equals to -1, and slope of AC dot slope of OP equals to -1. This is the conditions of perpendicular lines. We will use these conditions to find the value of orthocenter. For circumcenter and incenter, let me provide you the idea in next page, or for circumcenter I can provide in same page also. I have told that circumcenter is the point of concurrence of the perpendicular bisector. That means if this one is x1 y1, this one is x2 y2, and this one is x3 y3, suppose this is C point, and this point will be x1 plus x2 plus x3 y2, y2 plus y3 y2, right? So in this condition, suppose this is A B C M N O, right? So what we do, same, we use the same condition, M of CM dot M of AB equals to -1, like that of orthocenter, and M of CO dot M of AC equals to -1. The only difference in orthocenter and circumcenter is that in case of orthocenter we can't get the coordinates of M, N and P, but in case of circumcenter we easily gets the coordinates of M, N and O, these coordinates, because these are the perpendicular bisector. So this will be x2 plus x3 by 2 and y2 plus y3 by 2, but there was no knowledge given in orthocenter definition that that can easily help to find the value of M, N and P, right, like that of circumcenter. So the only part that is now left is incenter and the conditions of concurrent lines, and I have equation of bisectors, that is obtuse angle bisector and the acute angle bisector, right? So let's go to the next page. So I have told about this. So the only part that is left is incenter, right? What is incenter actually? Just drawing this. What we normally do if coordinates are given, we normally suppose this x1 y1, x2 y2, x3 y3, this distance is A, this distance is B, this distance is C. What we normally do, we normally use the formula ax1 plus bx2 plus cx3 over a plus b plus c. These are the distance, right? BC distance is A, AC distance is B, and these are the coordinates. Then the incenter coordinate will be ax1 plus bx2 plus cx3 over a plus b, just as A of x1, B of x2, like that, C of x3, and in the similar way we write A of y1 plus B of y2 plus C of y3 over A plus B plus C, right? This is the way we normally calculate the value of incenter, the coordinate of incenter. So I am going to the last topic, that is concurrency, point of concurrency and the angle bisectors, right? So just a minute, I am going to the next page. For that it would be then clear. So you know that concurrent lines, what we do, suppose the three lines are a1x plus b1y plus c1 is 0, a2x plus b2y plus c2 equals to 0, a3x plus b3y plus c3 equals to 0. These are the three lines. So what we normally do, we are calculating the value of x and y from these two equations, and if this satisfies the third equation, then we say that the three lines are concurrent. In another way, what we do, this is the first method I have told, but the most expensive and the most important that we will readily use in concurrency, that will help you. I don't know it is you know the determinant or not, but still, if you use the determinant form, then it would be much easier, right? Writing the coefficients and evaluating with 0. If this condition is true, then we can say that the three lines are concurrent. And in another way, what we can do, some other ways are also there. Suppose this is L1, this is L2, and this is L3. If L1 is multiplied with a constant and then do the sum, that is equals to 0, lambda i's are non-zero, right, constant. So if this condition is true, then it is also concurrent, but in most of the problems we will use the determinant form, right? So you have understood the point of concurrency. Now the last portion in straight lines, so far what I can remember is that equation of bisector of angles, that is angle bisectors of two straight lines. Suppose the straight line is this and this, angle bisectors. So let us consider the two straight line like this. The equation of angle bisector will go like this, because this is theta, then this must be theta by 2, so that we can say this is the angle bisector. Suppose the equation is, this equation is, suppose a1x plus b1y plus c1 equals to 0. I am writing the two straight line equation, just a2x plus b2y plus c2 equals to 0, right? So suppose a point B lies on the angle bisector, and we draw we draw a perpendicular to the given straight lines. Suppose the point that intersect the two straight line is M and N. From the definition we can say that BM equals to BN always. Suppose the coordinate of that B is, suppose HK, then what I can write, the formula, that is the distance of HK from the line a1x plus b1y plus c1 equals to 0. That is, we know the formula is a1h plus b1k plus c1 over root a1 square plus b1 square. And another bn we can write a2h plus b2k plus c2 over root a2 square plus b2 square. We use the mod, for the distance. So whenever we are changing the hk into xy, that is the locus of hk will be a1x. locus means a path followed by a moving point. Suppose this moving point is moving like this. This path is known as locus. Suppose this is the definition of locus. I am not using mod. Instead of that, I am using plus minus, right? 2 over root a2 square plus b2 square. This is the equation of angle bisector, right? So there will be two angle bisector. One will be obtuse angle bisector, another will be acute angle bisector. How to say which one is obtuse, which one is acute? So to learn that which one is acute and which one is obtuse, what we do, we normally see the value of that tan theta by 2. If the mod value of that tan theta by 2 is less than 1, that implies that the equation is corresponds to acute angle bisector. If it is greater than 1, then the line corresponds to obtuse angle bisector, right? And perhaps the family of lines. Whatever I know about this family of lines means, suppose this one is L1, this one is L1, this one is L2, then family of line equation is L1 plus lambda L2 equals to 0. This is the family of lines. I hope this much you have in straight line, but apart from that I will be discussing a bit more about the equation of straight lines, which makes an angle alpha with y equals to mx plus c, that is axis rotation. We will be discussing, right? Before discussing axis rotation, we must go to the new note. So the last topic is axis rotation. We normally use the matrix form, that is suppose the axis is rotated at an angle theta. If theta rotation, then what the new coordinates after rotation becomes like this, and that derivative of cos theta is minus sin theta. The derivative of sin theta is cos theta, and it will be x y. This is the form, right? So from here we can say x dash equals to x cos theta minus y sin theta, y dash equals to y cos theta, x sin theta plus y cos theta. Suppose we need to find the equation of straight line. Suppose equation of straight lines through a specific point. Suppose we define the point as x1 y1, that makes alpha with, suppose y equals to mx plus c. You will find in many questions that you will get this type of problem, that you need to find the equation of straight line through a specific point that makes alpha with a given line, that is y equals to mx plus c form, slope intercept form. Then what you will do, you will get two straight line. The formula of that you will write in this manner. You need to memorize this one, because if I want to derive this, it will take a longer time, and ultimately you will not you did not need to go through the derivation part. You need to solve by this formula, right? Wow. Whenever the derivations are required, I would definitely do the derivation, which will help you to understand the further concept, right? So these are the two equations, m plus tan alpha by 1 minus m tan alpha, right? This is the new slope, m plus tan alpha over 1 minus m tan alpha. Clear? And one small problem I am just saying, just note it. You must know that for a equilateral triangle, orthocenter, centroid, circumcenter, incenter, they coincide each other, right? And the circumcenter of a right angle triangle is the midpoint of its hypotenuse. If I draw, suppose this is the right angle triangle, the circumcenter is the midpoint of the hypotenuse, this one, suppose for a, therefore midpoint of the hypotenuse is equidistant from the 3 point. So I have shown this. So this is what you will go through in straight line. You will not get more than that, I think, but if you found more, then you please go through the book, any book you can go. There are many JEE level books are there at the end, so you can go through that. If you find new things are there, you will try to understand that. I guess whatever I have taught in the 2 sessions, this is much more. You don't need to go through some other concepts or like that. I have gone through some extra concepts also. So this is whatever you will go through, and try to solve problems related to this type of things. And I, in the next lecture, that will be the last lecture of straight line, I will just provide you some sums, or I will just come up with some numericals, and I will, for the shortage of time, I will also in Windows Journal I will solve that. And whenever I will teach, I will just discuss that how I have approached the numerical, right? So that's end for today. I hope this will help to get some more insight about straight lines. Please go through the book, any book you can go, and try to solve as much problem you can. Thank you.